Lesson 5.5 is entitled Inequalities in One Triangle. We're going to take a look at comparing the side lengths of our triangle and also taking a look at comparing the angle measures. And the question posed here is, what do you notice about the longest side of this triangle compared to the largest angle? Well, hopefully what you notice, our longest side and our largest angle, well, they are across from each other, or they are opposite from each other, and that is always going to hold true. Similarly, the smallest angle and the shortest side are going to be across from each other or opposite each other. And that is the main point in lesson 5.5. So the angle-side relationships in our triangles says if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So looking at my triangle here, I know that the angle Z would have to be greater than angle X. Angle Z would have to be greater than angle X. Similarly, if two angles of a triangle are not congruent, the longer side is opposite the larger angle. So here, my larger angle pointing to side, or opposite from side KL, KL is going to have to be greater than side JL. So they're going to ask us to do some comparing today. If you take a look at example A, they're wanting us to list our angles of triangle PQR in order from smallest to largest. Now, probably one of the biggest challenges is that you need to make sure you read directions if they want it from small to big or big to small. In this case, they want smallest to largest. So I take a look at my triangle. Just looking here, my smallest side is 7.5. It is across from angle Q. So angle Q is going to be my smallest angle. Angle Q, if I'm listing in smallest to largest, well, the next smallest side would be 8.8 across from angle R, followed by angle P, my largest angle. We can do that similar comparison in example B. Now, when they're asking me here to compare my side lengths, you'll notice that I only have my angle measures. It is a good idea. We're going to want to find our other angle, so we're going to subtract from 180 degrees. We would actually find out that this angle is 79. They want my side lengths from shortest to longest. So I am going to find my smallest angle, and it is across from side FH. So FH is going to have to be my smallest side. So we have side FH. My next largest angle is 56 across from GF, so that's going to have to be my next smallest. And then finally the 79 across from GH, the largest side. And that's how we compare our angle measures and our side lengths. Now, we're also going to talk about the triangle inequality theorem, and what that basically addresses is if we were given three segments, could we form a triangle? Not any three given segments you're going to be able to create or to form a triangle. You can see here that if I had the side lengths of 3, 3, and 7, I would not be able to form a triangle with those. The side lengths of 3 and 3 are too short to connect or to form my triangle. So what does that mean? Well, that means that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. And basically you can summarize that by saying your two small sides need to add up to greater than your third side. If I were looking at my triangle here and I were comparing my lengths, my side PQ plus my side QR is greater than the length of PR. My two small sides are greater than my third. So looking at example C, they're just simply asking us if we can form a triangle with the given side lengths. So we are going to check our two small sides, 8 and 15. My large side is 17. Is 8 plus 15, how does that compare? Well, yes, that's greater than 17. So this will form a triangle. Now you'll notice in number 2, my side lengths are quite in order. I'm checking my two small sides. Well, 2 plus 8 is not greater than 11. And so these would not be able to form a triangle. They would not reach to connect. Example D, they're asking me about two given sides. They want to know what would the range for the measure of the third side be. If my two sides of a triangle were 3 and 7, what are the other possibilities for my third side? Well, there's a couple ways that you can think about this. If 3 and 7 were my two small sides of my triangle, 3 plus 7 would have to be greater than that third side. So this tells me, well, 10 would have to be greater than S, or S would have to be less than 10. But there is also the possibility that maybe 7 is the longer side, or the longest side. So we also need to compare, this is kind of the upper bound, but what about the other way if we looked at it? What if my side was one of my short sides, or my small sides? 3 plus S would have to be greater than 7. And if we look here, that would tell me that S is greater than 4. I could also turn that around and say 4 is less than S. You could look at that either way. Well, if you think about it kind of on the number line, that really tells me that it has to be between 4 and 7. And so if I were going to write this as a compound inequality, I would say that that side length, I'm going to say 4 is less than my side, but my side has to be less than 10. And that would be my final answer.